We're certainly proud to be part of the technology that enables such an important application, and we want to show it to you. So just to put this in perspective, he talked about digital twins. And some of you are probably familiar with that application in different areas. One of the areas you might be familiar with is like testing an autonomous vehicle, where you simulate the city block for maybe the real control hardware of the vehicle you'll hardware in the loop testing. But here, the challenge is you have a battlefield that's thousands of miles across. You have countless different devices, and some of them are actually adversarial. So it's a super challenging application. So we want to take a look at it so you can see it demonstrated. So to give us a sneak peek at RFView, please welcome Haydn Nelson from NI and Dave Kirk from Information Systems Laboratories.
How you doing, sir?
Hey, Dave.
All right. Kick us off. Thank you, Eric, and thank you, Dr. Meyer. I appreciate that explanation of the electromagnetic spectrum and how important it is to operations, and how test and data is going to play a critical role to fielding advanced radar and EW capabilities faster. So, Dave, we got a copy of RFView up here on stage. Yep. Why don't you talk to us a little bit about Information Systems Lab and what y'all are doing to advance this digital engineering revolution for radar tests?
Yeah, sure. Thanks, Haydn. ISL is a technology company focused on modeling and simulation to help engineers and service members simulate and train in a realistic digital environment. The software tool RFView pulls from classified and unclassified databases and allows engineers to simulate real, complex, real-world radar and EW scenarios, and take those simulations into the real world with a full hardware-in-the-loop environment emulation using NI RF transceivers and software.
So with RFView, you can simulate almost any operational scenario and environment, kind of like a virtual reality, but for radar.
Yeah, exactly. That's right. We use RFView with the NI RF transceivers technology to really simulate the very complex world around a radar in real time. And that can include not only clutter, but also other emitters, unintentional, intentional interference. That's really a very complex environment. And this really, by using this technology, allows us to test against many more of those threats than you ever could in the open range. Basically, it allows us to fly your radar anywhere in the world, right in your lab.
Well, so we got the radar spinning here. Why don't you tell us a little bit about what's happening here with this particular setup?
Okay, yeah, thanks, Haydn. So we have over here, this is a marine radar. It's actually transmitting out, coming out through the cable into the NI RF transceiver. It captures that pulse, convolves it with the environment that it would be seeing, which is where RFView comes in using LabView FPGA, then sends it back out to the radar. So whatever the radar is seeing, I guess I actually had to start this. And so as far as the radar is concerned, it's now actually flying right off the coast of Los Angeles.
So as you can see here, this is really interesting because on the right screen, this is RFView running in LabView, and you can see it's in Los Angeles. And here's the operator interface of the radar. And as you can see, the terrain data matches because of that terrain database that's running on the FPGA. And as you just saw, what just happened is it updated, downloaded a new terrain database to the FPGA, and now we're flying in lovely Yellowstone. Wonderful. It seems like we're flying this radar all over the place.
Yeah, absolutely. And as far as the radar is concerned, it really thinks it's there. And as Dr. Meyer explained, as RF systems on the battlefield become more complex, there's more emitters, interference, all sorts of things. The traditional testing methods that we've relied on over the years really limits the number of scenarios that you can test against, out in the field in the real world. But using RFView and the NI RF transceiver technology really gives engineers the tools to test virtually in whatever scenario they can dream up and be able to do that right in their lab. And that really maximizes the mission effectiveness of these systems for the warfighter and allows them to be fielded much more quickly.
Well, I appreciate the demo, Dave. It's a really good example how engineers are using NI technology to modernize radar tests. In addition to the NI and ISL solution, I am really excited to announce an all-new end-to-end radar test capability. This new offering today that we're announcing combines the 1 gigahertz bandwidth and the high frequencies of the vector signal transceiver with an all-new software driver that allows engineers to inject multiple independent targets into a radar for test, all in a closed-loop FPGA-based system. So a new capability for the VST. That's pretty cool. What's really cool about both of these solutions for me is this is going to give those engineers the tools to increase test coverage, which is going to lead to improved confidence in system-level performance of these systems before they are then delivered to the warfighter. And as Dr. Meyer mentioned earlier, this ability to digitally test earlier is going to lead to improved operational readiness and ultimately mission success. I invite you all to stop by the Defense Expo and take a look at both of these systems up close.
Awesome. Thanks, guys.
Thank you.
Very cool.
Thank you.